Let's summarize what we did yesterday. This was our data sheet, and we will work only on this board, not this board here. Input stage and output stage. So let's try to summarize what we did yesterday. Input current will look like this. And the current goes inside to the buck converter, and there's a switch, and then the current will flow through our variable inductor and then flow through our shunt resistor to the output. The problem was that what kind of signals do we have and how we can get it, since the output is constant. And the first idea was to measure the difference between these two test points. If we look at the voltages, for example, for TP11, TP11 is the output voltage. It will look like that. And the average of the output voltage will always be 3.3 volts. This is 3.3 volts plus minus voltage ripple. And if we look at the TP10, TP10 should be also should look like the same as the output voltage waveform, but TP10 it would be a little bit higher, for example 3.32 volts. Why? Because the maximum current that we can operate is 1.5 amps. Voltage across this resistance here. What kind of resistance is that? It has 1% of tolerance That means 1% of 0.01 ohms. It's too small. We can ignore it. And we will multiply let's say 1% plus minus. This voltage is actually very small. It was between, if the output current is minimum, we noted yesterday this voltage has a value between these two millivolts, and this is too small. The problem is in Arduino we will multiply the difference, for example, with a constant, let's say 1000, and we will go to the volt digits. This was the first idea, that we can measure these two test points. And the second idea was also measure between TP9 and TP11. So there is a voltmeter, and here the problem was the waveform of TP9 is actually has a rectangular waveform or square waveform, which has duty cycle of 50%. 50% would mean if I want to have 3.3 volts at the output, then input should be 2 times let's write the transfer function. Duty cycle, output, input. If it's 50%, input should be the double of the output voltage. So we will always test our measurement with 6.6 volts here at the input side. And the problem is that the difference between, in oscilloscope we used math 1 function, it was TP9 minus TP11, and this waveform is actually square wave minus TP11 has the sine function. And this was difficult to take into account for math, because we need always the average values of these two signals, this signal and this signal, or these signals. The advantage here, let's say math 2, TP10 minus TP11. this was a sine wave, and this is also sine wave. And the average value of two sine waves will give us a sine wave. And in Arduino, we can also operate with average value of this sine wave, and we would have the information for our current. And the third problem was, or the second problem was, we have Arduino here. And Arduino has several ADC channel, analog to digital. Let's say we need two channel. One is for TP11 and the second is TP10. We need these two information, two signals, and this is TP10. So the second problem was, this voltage is approximately 3.3 volts. And this voltage here is 3.3 plus current times the shunt resistor, let's say 3.32 volts. But the analog digital channel, the maximum voltage for Arduino, I shouldn't give voltage level which is bigger than 3.3 volts. If I feed this voltage into the Arduino, maybe it will cut, or I don't know what kind of op-amp is inside the Arduino. What is the supply voltage, VCC, of Arduino? You should check in Arduino what is the maximum allowable voltage signal that I can feed here. If it's okay, for example, if Arduino tells me that you can feed the channels with more than 3.3 volts, for example, with 5 volts, then the op-amp can work with these voltages. If so, then the work is actually very simple. We will write a code in Arduino it says, for example, voltage difference, which is the average voltage of TP10 minus let's make it a little bit bigger. Okay. Minus again the average voltage of TP10, and it will give me approximately, let's say, 0.02 volts, and we will multiply this value with a constant, for example, let's say times 100. 2 volts difference would, for example, mean for me that output current is 1.5 amps. Or if the difference is smaller, let's say 0.5 amps, this difference will be smaller, and in this case, let's say 0.7 volts for 0.5 amps. So that's all. I tried to summarize it. If you have any questions, if it's not clear, for example, the waveform of the current here looks like triangle, and we have a jumper here, and up to this point it's always triangle, but this cap will smooth the voltage. Now the output voltage here would look like a sine wave, and this cap will take the AC portion of this current, and the rest would be a constant DC current. Yeah.